Now it's time for you to learn about sequence diagrams. Sequence diagrams are used to show your team how objects in your program interact with each other to complete tasks. Simply put, think of a sequence diagram like a map of conversations between different people, where this map follows all the messages sent from person to person. Let's say that a person wants to order a burger at a local fast food restaurant. Here is a simple sequence diagram of this scenario. That person will go to a restaurant and talk to the cashier and order a burger. The cashier will then talk to the chef at the back to tell him the order. The chef will cook the burger, give it to the cashier, and the cashier will give it to the person. Now let's go into more detail. Because a sequence diagram is another type of UML diagram, to fully understand it, you should have a good grasp of objects and basic UML class diagrams. Knowing how to break down a system into classes is essential in creating meaningful sequence diagrams. A sequence diagram describes how objects in your system interact to complete a specific task. Think back to the burger example. All those interactions between the different people were needed so that person could get a burger. This is similar to how objects will interact to complete a given task. I will describe the different components of a sequence diagram first, then later I will elaborate more on how to put it all together. When creating sequence diagrams, first you use a box to represent a role played by an object. The role is typically labeled by the name of the class for the object. Second, you use vertical dotted lines, known as lifelines, to represent an object as time passes by. Finally, you use arrows to show messages that are sent from one object to another. Now that you know the different elements, let's put everything together by creating a sequence diagram. Let's use changing the channel of your television using a remote control. First, I'm going to start by drawing out a box that will surround the entire process. This is to show that this is one sequence of activities. A sequence diagram can contain other sequence diagrams within it. For example, if you are creating a sequence diagram for an ATM, there might be a different sequence for withdrawal and deposits, and during a single process, someone might want to do both. In your sequence diagram, you would have one big sequence of activities, with two smaller sequences inside them. Moving on, in the top corner, I'm going to draw a label with a meaningful title. Remember, your team will be looking at this diagram as a reference for development, so make the titles meaningful. We will name it Change TV Channel. Next, I'm going to draw out the objects that are important in this task. To keep things clean, you should draw objects from left to right in the sequence that they interact with each other. In this example, the TV viewer starts the entire process. They use a remote, which will then interact with the TV. So in our diagram, I'm going to draw the TV viewer, then the remote, and then the TV. If there are people in your example who will be using or interacting with objects, these are typically drawn as stick figures. We call these people actors. In our example, the TV viewer is an actor, so I'm going to draw them as a stick figure. I'm going to draw the other objects as labeled boxes. Each of these objects has a lifeline. The lifelines you can draw as a dashed line projecting downwards from the object. Now I'm going to start drawing the messages that are sent from object to object. In a sequence diagram, if one object sends a message to another object, or objects, we denote this by drawing a solid line arrow from the sender to the receiver. To return data and control back to initiating objects, we would use a dotted line arrow. What's the first thing that happens in this example? Let's assume the TV is already on, and the TV viewer wants to change the channel. The first thing that happens is the TV viewer presses the numbers on the remote to tell it which channel to go to. This activates both TV viewer and the remote in our sequence diagram. When an object is activated, we denote this on our sequence diagram using small rectangles on the object's lifeline. You activate an object whenever an object sends, receives, or is waiting for a message. The first message that is sent is from the TV viewer to the remote. That message says that the TV viewer pressed numbers. So I'm going to add this to the diagram with a solid line arrow and label it Press Numbers, Number. The remote then sends a new message to the television to change the channel to number. We denote this on the diagram with another solid line arrow labeled Change Channel, Number. This also activates the television object, so I will add a small rectangle to the television's lifeline. You'll notice that since the television wasn't activated at the beginning of the example, we don't want the rectangle on its lifeline to start at the same place as the TV viewer or the remote. I drew it a little bit lower on the lifeline to indicate it was activated later in the process. Next, the television changes the channel, which the TV viewer can see on the TV screen. This is a returning of control. That means I'm going to denote this response using a dotted line arrow. I'm going to draw this arrow from the television object to the TV viewer. This action only affects the television and the TV viewer. The remote is not part of this interaction, so we do not extend the box on the remote's lifeline to include this action. As you design software, your sequence diagrams can get much more complicated. You can also show loops and alternative processes in a sequence diagram. Let's see what these would look like in a sequence diagram. Say the TV viewer is unsure what channel to go to and would like to surf the channels until they find a channel they like. I can wrap the previous sequence I just drew as part of an alternative process, so that it is a sequence of actions that will occur if a condition is true. So I put the sequence in a box and label it alt for alternative in the top right corner. Now I need to specify when this alternative will occur. In this case, the sequence occurs if the TV viewer knew what channel they would like. We will label this alternative TV viewer knows what channel they want. If the TV viewer does not know what channel they want, other sequences can occur. One sequence is that the TV viewer will browse through the channels until they find something to watch. So I'm going to draw this sequence underneath the previous sequence with the condition else, meaning this sequence occurs if all other alternatives are false. However, this sequence contains a loop. I will denote that by adding and labeling a box loop in the top right corner. Right under the label, I put the conditional statement for the loop. If that statement is true, it will go through the loop. The loop sequence should continually occur if the TV viewer does not like the channel they are watching, so I will add that condition to this loop box. The TV viewer is going to press the up or down arrow on the remote to browse through the channels. This sends a message to the remote. The remote will then send a message to the TV with this action. Just like in the initial sequence, the TV changes the channel and displays that to the TV viewer. The final sequence diagram looks like this. Sequence diagrams are a very powerful tool you can use to model your software. Sequence diagrams are commonly used as a planning tool before the development team starts programming, or to show others how a system is designed. You can now use sequence diagrams to help you visualize the classes that you will create in your software, and they can help you to determine the functions you will need to write. It might even help you find problems in your system that you didn't see before. Sequence diagrams are another technique you now know that will help you to create clean, well-designed programs.